Hi Algebra 1 students. This video is going to be in your workbooks today. So this is the Module 5 workbook, page 21. So if you turn to page 21 in the Module 5 section of your workbook, then you should see this same exercise at the top of the page. And I'm going to kind of walk you through each part of it. So it says, Eduardo has a summer job that pays him a certain rate for the first 40 hours per week and time and a half for overtime. The graph below is a representation of how much money he earns as a function of the hours he works in 1 week. Okay, so we see time in hours along the x-axis, earnings in dollars along the y-axis, and we kind of see that there are these two different pieces, right? So we see something going on at 40, where we're switching from one slope to another slope. And we can think about why is that happening? Well, it's probably happening because it says he makes a certain rate for the first 40 hours, but then after that, he makes time and a half. So the slope is getting steeper to represent his hourly wage is going up to what he was making before plus half of that, okay? So we're going to kind of go through the modeling process to come up with a function that represents the situation here. So first of all, there is like another piece to this problem that they're trying to have us answer, which says Eduardo's employers want to make him a salaried employee, which means he does not get overtime. They want to pay him $480 a week and have him work 50 hours a week. Should he agree to the salary change? So this is a really great example of a real-world situation where we can use modeling to come up with a solution. So like right now, we're not exactly sure if he should switch or not. Is this $480 a week going to be more than he would make based off of this situation up here in the graph? Okay, so that we're going to come back to that question at the end once we create an equation. So part A says, first of all, what type of function can be represented by a graph like this? Quadratic, linear, exponential, piecewise, square root, or cubed root? So first of all, we see up here there are two different pieces. There's one piece that goes up until 40, and then there's a second piece that's steeper. And we see that each piece is a straight line. So our conclusion here can be that we need a piecewise linear function. Okay? How would you describe the end behavior of the graph in the context of this problem? So end behavior, we're not going to do too much with end behavior right now, but end behavior is what's going on as your x values increase, what's happening to your y values. So if you think about this, if we kind of keep going, as our x values will keep increasing, our y values also keep increasing. Okay? So we can say as x values increase, so do y values. One other thing to note here, though, is that we won't really be increasing our x values to like really, really big numbers, because if this is time in hours you work a week, there's only so many hours you can work in a week, right? Because there's only so many hours in a week, and you also have to sleep and do other things. So one thing to think about here is that realistically, there's a limit on the number of hours he can work. Number of hours he can work in 1 week. Okay, so now I'm going to turn to the next page, and we're going to keep kind of referring back to this graph. So you may have to kind of flip back and forth. But on the next page, it says, how does this affect the equation of the function? So the idea there is like, what is our end? It's asking about what is the end behavior telling us about the equation. Well, if as x increases, so does y, that would mean that our equations should have a positive slope. We should have positive slopes. Now we're going to have to write two different pieces of the linear equation because there's going to be a different equation for the two different pieces of the graph. So the idea of computing that equation. It says, what strategy do you plan to use to come up with a model for this context? So I'm going to give you guys a strategy here, and this is something you'll always be able to use. But the idea will be we can find the slope and the y-intercept for each piece of the graph, and then write the piecewise function. And so now I'm going to kind of walk you through this process, okay? So first of all, if you remember what a piecewise function looks like, we're going to call this f of x, and then we would say f of x equals, and then we put these little like curly brackets, and I'm going to end up writing in two different equations, and each equation has a different part of the domain, or a different range of x values, so the idea would be the first one we would say is for a certain x values, and the second one is for a certain set of x values. So I think I'm going to fill in what x values first. So if you're going to go back to the graph, we can see that the changing over place between one line to the next. So we have one chunk and then another chunk. The changing over x value is at 40. So the first equation I'm going to write is going to be from 0 to 40, and then the next one is going to be when x is greater than 40, and that's going to cover everything else. Okay, so I'm just going to write that down. So we would say for here I'm putting x in between 0 and 40, so I'm saying 0 is less than or equal to x, which is less than or equal to 40. For the second one, I'm just going to say for x greater than 40. Now we still need to come up with what goes in those two pieces, right? So in order to do that, we're going to use the points we were given on the graph for each piece. So I'm going to kind of call the first one piece 1. And piece 1, if you go back to the graph, we have 2 points that we know about on piece 1. We have 0, 0, and we have 22, 198. So we're going to use those 2 points. So I'm going to write those down here. And then I'm going to find the slope first. So if I have 2 points on a line, I can always find the slope, m, by doing y2 minus y1 over x2 minus x1. And in this case, that would be 198 minus 0 over 22 minus 0. Which is, if you do the division, it's 198 divided by 22. That's 9. Okay, and then if the whole goal here is going to be that we're doing a y equals mx plus b type equation, so I just found m. And then to find b here, well, b, if you look, we can actually see the y-intercept, that's b, on the graph. The y-intercept is at the origin, right? If we slide this over, we can see that this line segment hits the y-axis at the point 0, 0. So that means that my b value is just 0. So then what's the whole equation here would be just 9x plus 0, and that's just saying 9x, right? So what I'm going to do with that is that's going to be the first piece of my piecewise function over here. I'm putting in 9x for x between 0 and 40. Now I need to figure out the second piece. So to do piece 2, I need to kind of go back to the graph and see what points I'm given. So if you look at the graph, it's kind of hard to read the points, but the points are 60, 630, and 70, 765. And if you're confused about where those numbers are coming from, let me just quickly show you on the graph. Those are these 2 points. Okay? So the idea is I'm going to find the slope between those 2 points, and that's going to be the slope of this second piece of my function. So again, I'm going to do y2 minus y1 over x2 minus x1. That's going to give me 765 minus 630 over 70 minus 60. And that's going to be 135 over 10. So we're going to get 13.5, and that's going to be m for the second piece. But here, to find the b value, to find the y-intercept here, it's going to be a little bit different. It's going to be a little bit more challenging because if you look on the graph, we can't really tell where the y-intercept would be for this line. We can kind of see that if we were to kind of extend this line out, it's going to be something negative, but we can't quite tell exactly what that is. So I'm going to give you another strategy for finding b. So to find the b value, we're going to plug in m equals 13.5, and we're going to plug in one of our coordinates. I'm going to use 60, 630 as x, y, and I'm plugging those in to the generic y equals mx plus b. Because the idea is that if I know x, y, and m, then I can solve to find b. So I'm putting in y is 630, m is 13.5, x is 60, and then b is my unknown. From here, I'd multiply 13.5 times 60, which is 810. So I get 630 is equal to 810 plus b. Subtracting 810 from both sides, I get negative 180 is equal to b. And now, what do I know? Now I'm able to write my entire equation, because now I know m and b, so it would be y equals 13.5 x minus 180. And that's what I'm going to write in this last piece of my piecewise function up here. But I don't need the y equals, because that's like my f of x over here. So I just need 13.5x minus 180. And that is just a quick video for how we create the piecewise function. What I want you guys to do now is, can you go back to the original question, which was, should he switch to a salaried position making $480 a week? Should he switch back to that, or should he stick with his current model? So think about how you could use this equation to answer that question. And we're also going to go over we're going to do some more practice with this in class.